All right, we're going to be finding the domain given the equation of a function, guys. Now, I like to break these up into two sections, the ones without restrictions and the ones with restriction. So I am going to start with the ones that have restrictions, okay? So if you're given a function, you have to find the domain, just the domain. Remember, the domain are your x's. Of the function. And of course, you have to write it in interval notation. So the first ones we're going to look at are the ones without restrictions. So when we do the ones without restrictions, it means that the domain is all reals. And if the domain is all reals, when you express it in interval notation, the interval notation would be from negative infinity up to positive infinity. So what functions have a domain with no restriction, guys? All the polynomials, starting off with the polynomials. What are we talking about? We're talking about any constant polynomial, like f of x is equal to some constant. F of x is equal to x. Oops, I forgot to put that equal sign there. So let's go back a little bit. Okay, f of x is equal to x. F of x is equal to x squared. So any polynomial, guys, of any degree, the domain is not restricted at all. So any type of polynomial, there's no restrictions on the domain. Now, another one is the absolute, oops, I'm spelling that, okay? That is the absolute value function. Now, we saw the absolute value function last week when we talked about the transformations. So f of x is equal to the absolute value of x. Yes, guys, that one has no restrictions. You can plug in positive x's, you can plug in negative x's, you can plug in 0. So pretty much, how do you know function doesn't have any restriction? If you can plug in a positive value, a negative value, and 0 and always get an output, then no, it doesn't have any restrictions. Here's another one, guys, without restrictions, okay? Hold on a second, let me clear this one out. And we're not talking about this until we get to chapter 4, but these are referred to as the exponential functions. And the exponential functions, we'll see them in chapter 4 in the form of, let me spell that too, f of x is equal to maybe 2 to the x power, or f of x is equal to b to the x. These types have no restrictions in the domain. So you can plug in any x value in here and always get an output. So guys, let's focus on the ones with restrictions. Those are the ones that you really need to focus on, the ones with the restrictions. And the ones with the restrictions are the ones that you're going to see on the test, so pay careful attention. Starting off with the square root function, guys. The square root function. Now, when we look at the square root function, it's in the form of f of x is equal to the square root of x. We talked about this last week when we talked about the transformations. And so the square root function has a domain, guys. The domain of the square root function is all x's greater than or equal to 0. All x's greater than or equal to 0, meaning you can substitute positive x values into the function. You can also substitute 0. However, you cannot substitute a negative into a square root function, because when you take the square root of a negative value, it is undefined, guys, okay? So the domain, when we write it in interval notation for the square root function, will be from 0 included up to positive infinity. All right, so now let's go ahead and look at some example problems, guys. Now, for the example problems, you will see them on the assignments as well as on the test. Pay careful attention. I will tell you which one you're going to see on the test, okay? So let's say you're given this function right here, and the question is, what is the domain of this function? Remember, the values you're allowed to plug in to this function are anything greater than or equal to 0. So then you would take the expression inside the root, set it greater than or equal to 0, and solve this to find the domain, of this radical function, guys. So the domain of this radical function would reflect every value greater than or equal to -3. But then we have to write this in interval notation. So in interval notation, it will be bracket -3, comma, up to positive infinity, and then close it off. And that's it. Okay, now I'm going to do another one, guys. Number 2, f of x is equal to the square root of negative x minus 2. I know you guys see that negative in front of the x, that negative coefficient of x, but don't worry about it, guys, because if you plug in a negative in for that x value, it can definitely cancel out the negative, so it's okay for now. So to find the domain of this one, we'll take the negative x minus 2. Again, set it greater or equal to 0 and solve this out. So you would add 2 to both sides. So you get negative x is greater or equal to 2. You're not allowed to have a negative variable, so get rid of that negative by multiplying both sides by negative 1 or just a negative. And what is going to happen with that inequality symbol? It's going to have to reverse to reflect every single value less than or equal to negative 2. But then, of course, you have to express this in interval notation, guys. So in interval notation, this would represent every value from negative infinity up to negative 2. So these are the numbers that you can plug into this function, guys, for x, and always get an output. Any questions on this one? If you see one like this on the test, the question you have to ask yourself is, will I be able to do it? If you cannot do it, you should ask a question.
I have a question. So
yes.
With when you're doing square root functions, you just take the square root away. You don't do anything to get rid of it, and you just put it in interval, or not interval.
The square root determines the shape. The square root determines the shape. And then the domain here tells you which values you can plug in for x.
Okay, great.
All right, guys. So here comes the next one with restrictions. The rational or the reciprocal function. The rational or the reciprocal function. Now, we're not going to study these that much in this chapter. However, you will see them in chapter 3. We'll study them in chapter 3, guys. And the reciprocal or rational function, these are the functions with a variable in the denominator. Functions such as f of x is equal to 1 over x. And the minute you see that variable in the denominator, guys, your thought should be, what value will make the denominator 0? What value should be excluded from the denominator, because the denominator of a fraction cannot be 0. So in the case of this one, the restricted value would be 0. So you can plug in any value into this function for x except 0. So essentially, you could say the domain is all reals except x cannot equal to 0. Now the question is, how do you express this in interval notation? You include everything but 0. It would be from negative infinity up to 0, but 0 is not included. And then union from 0, not included, up to positive infinity. So this is how you would express the domain of this rational function in interval notation. Now, here's the problem, guys, you are going to see on the test. And this one right here is a rational function, f of x is equal to 2x over x squared minus 2x minus 8. So on this one right here, guys, we are going to, hold on a second. Okay, there we go. All right, so on this one right here, guys, it's a rational function. So the first thing you have to think about is, what values would make the denominator equal out to 0? Whatever those values are, you want to restrict them from being a part of the domain. So what you do is you set the denominator equal to 0 and solve it, guys. And that will give you the restricted values. And then you use that to write your interval notation. So x squared, ooh, Shazam. Let's try that again. X squared minus 2x, my pen is not writing, guys. So let's try it again, okay. X squared minus 2x minus 8, set it equal to 0. That's a beautiful quadratic equation. We're gonna solve it. Let's factor it. X minus 4, x plus 2. What two numbers multiply to give you negative 8 and add to give you negative 2? That'll be minus 4, positive 2. Now, you wanna set each factor equal to 0 and solve. As in, what number minus 4 makes this parentheses 0? Positive 4. What number plus 2 makes the second parentheses equal to 0? Negative 2. So those are your two restricted values. These are the values that would make the denominator equal out to 0. In other words, you can plug in every x value except 4, or -2. So now how do we write this in interval notation to express that, guys? Here's how we write it. Think of it like this, guys. If you're on the number line, here's your -2, okay? This would be open. +4 would also be open. So basically, you have a set of solution over here, a set of solution in between, and then you have a set of solution from -infinity up to -2, but -2 is not included. So everything except -2, +4. So when you write this in an notation, you would do -infinity, comma, -2, close it off with a parentheses, union, now we're gonna do the middle region right here, the middle region, okay, from -2, which is not included, up to 4, which is also not included, and then union, you wanna do this third region, the region to the right over here, okay? So that region to the right would be from +4 up to infinity, guys. And this would be your interval solution. So guys, be careful with this one, absolutely on the test, and it is going to be a full response question. So,
Response, do you mean like we have to draw the graph and everything as well?
no, this is not about drawing the graph. This is simply about finding the domain.
Okay.
Yeah. All right, now guys, here's a special case. And this one, it always appears on the test, so pay careful attention to this one. For this particular problem right here, it's 1 over f of x equals to 1 over the square root of x minus 3. So essentially, you have a combination of two functions here. You have the square root function because it's in the denominator. You also have a rational function because you have a variable in the denominator. So for this one, you have to think about the restrictions. First, guys, the restriction for the square root function, remember, you can't have, okay, negative values for the square root function. So all the x values must be greater or equal to 0. And then for the rational function, if you got on 1 over x, x cannot equal to 0. So you've got two restrictions to take into consideration here. So guys, be careful with this one. For this particular problem, because the denominator cannot equal to 0, when you set this up to find the domain, you cannot do x minus 3 is greater than or equal to, but rather you're just going to have to do x minus 3 is greater than 0. Why are we just doing greater than 0? Because we don't want to make it equal to 0. If we make it equal to 0, then we would end up with a problem that's undefined. The denominator would be 0 or undefined, guys. So you can't do that.
I have a question.
Yes.
So if this was just the square root of x minus 3 without the fraction, it could be equal to 0.
Absolutely.
But because it's a fraction, it can't be 0 because of the denominator can't be
Right,
0.
because the square root is in the denominator, right?
Okay, just making sure. Thank you.
That's fine. So guys, this would be the domain of this function. Every x value greater than 3. And of course, you have to express this in interval notation. And so guys, you go ahead and rewrite this as 3 with the parentheses up to positive infinity. Now, let me go ahead and give you guys a little hint here. Let's say you have no clue what the domain should be. Guys, check it out, test it out, check it, experiment with it. For example, if you're not sure 1 is a part of this domain, take 1, plug it in here for x, guys. 1 minus 3 gives you -2. Can you take the square root of -2? Nope, you can't. So the function is not defined there. Let's try 0. If we try 0, 0 minus 3, that's going to give us a -3. We cannot take the square root of -3. That won't work. Let's try 3. 3 minus 3 is 0. The denominator would be 0. We cannot use the 3, guys. Well, what if we try 4? 4 minus 3, that's 1. Can we take the square root of 1? Absolutely. So yes, this function, guys, is defined when x is equal to 3. So when x is equal to 3, the function is located at +1. So when you graph it, guys, this is one of the points on the graph. So be careful with this, okay? So guys, those are some of the problems that you're going to see on the test. Once again, if you're not sure, guys, test it out, experiment with the problem, okay? So I am going to go ahead and move on now to lesson 1.6. And guys, once again, this is going to go by very quickly because these next 3 lessons, The information in there is very minute, and so we're not going to spend that much time in there, okay? So we're starting off with the composite functions. This is probably the longest out of the three, so pay careful attention because most of you have probably never worked with composite function. If you have, that's awesome. If you haven't, this is your first time, guys. Give it a few examples for you to understand what's going on with the composite functions, okay? So when we talk about composite functions, guys, this is where we are combining two or more functions to create a new function using substitution. We are going to take two or more functions, combine them together using substitution to create a brand new function. Now, normally, guys, if I had a longer period of time, I would go into combining these functions using the four basic operations: addition, subtraction, multiplication, division, but I don't have that much time, so I'm just going to go straight into the composite functions because that's what you guys really need. The other combination of functions, you guys can discuss them in pre-calculus for those of you who are moving on. So guys, listen, these composite functions, there are two basic composite functions. The first one is the f of g of x. Here, let me write this down for you. F of g of x. That's how you say that, guys. F of g of x. This can also be expressed as f of g, that's of, okay, that's not multiplication, of x. This is just notation. This is another way for you to write the composite function, guys. AKA, sometimes people refer to it as fog. Yeah, all right. So what does the composite function f of g of x do? What you do is you substitute, guys. My pen will not write, okay? This is where we're going to substitute g of x into f of x to create the new function. We take g of x, we substitute it into g of x, into f of x to create the new function, guys. So in order to do this, I'm going to start off with an example, guys. So here we go with our example problem. Let's say I have the function f of x is equal to 3x plus 4, while my g of x function is equal to 2x minus 1, okay? So now I am going to go ahead and create f of g of x, the new function f of g of x. In other words, I'm going to take the g function, plug it into the f of x function. So I'm going to take what g of x is equal to, and then go into the f function, plug it in for x. So guys, on this one right here, we're going to do f of g of x, but the g function is 2x minus 1. So I'm just going to go ahead and substitute that in there. So when I plug it into the function, guys, this is what I'm going to end up with. That's the substitution right there. Okay. So now, oh, I don't need that parentheses there. So now I am going to distribute the 3. So I get 6x minus 3 plus 4, and then combine like terms. So the resulting function would be 6x plus 1. And this resulting function, we refer to it as f of g of x. So when we combine f of g of x together, this is the brand new function, guys. So that's the first one, okay? Now, there's a second one. So here comes the second one, guys. The second one is referred to as g of f of x. And then another way to notate this is g of f of x, aka the goth, okay? So in this one right here, we are going to substitute, all right, f of x into g of x. We take f of x, we plug it into the g of x in order to create the g of f of x. So guys, I am going to go back to the same two functions I gave you in the previous example, 3x plus 4, while g was 2x minus 1. So in this one right here, guys, I am going to take the f of x function, which is 3x plus 4. I am going to go into the g function and substitute that in there for g. So g of f of x, guys, will equal to g of 3x plus 4. So I'm going to plug it into the g function. So I do 2 times 3x plus 4. And then minus 1. Now we're going to distribute the 2. So we get 6x plus 8 and then minus 1. Combine like terms, so you get 6x plus 7. Now guys, notice this one right here is 6x plus 7. The other one was f of g of x. The other one, it was 6x plus 1. Notice they're not equal to each other. So don't assume that g of f of x and f of g of x will be the exact same thing. Now, the question you might be asking yourself is, will there ever be a time when they're equivalent to each other? Will that ever happen? Okay, so we'll put that question on the table somewhere and come back to it later on, guys. So these are your two basic composite functions. Now, additionally, guys, they will ask you to evaluate the composite functions. Now, if they ask you to evaluate the composite functions, you might see something like this. Find f of g of 2. And remember, the two functions we've been working with are f of x is equal to 3x plus 4, while g of x is equal to 2x minus 1, okay? Now, what I recommend to students is this, until you feel comfortable. Listen, guys, you want to go ahead and take the 2, plug it into g. The answer you find, you're going to take it and plug it into f. So go ahead and look up, stop writing for a moment, and let's go ahead and analyze this, guys. So what you do is you take the 2, you go into the g function, plug it in. So you're going to calculate the value of g of 2. And then you get 4 minus 1, 4 minus 1 gives you 3. Now you take that 3 becomes the input for the f function. So you go into your f function, guys, plug it in here, 3 times 3, and then plus 4, and work it out. So for this one, you're going to get 13. So guys, the outcome for this problem is 13, as in f of g of 2 turns out to be 13. So when we input 2 into f of g of x, the corresponding output is 13. Now, is there some way we could verify this? Of course. We did f of g of x earlier, guys. And the answer was 6x plus 1. That was the function for f of g of x. Well, they just want us to find f of g of 2. So since they want us to find f of g of 2, we can just go ahead and take that 2, substitute it in for x, work it out. Look at that, guys. This is another way of verifying the answer right there. Same thing, the exact same thing. Okay, I'm going to do a couple more examples, so hang on. If you did not get that one, I'm going to do another one, and I am going to do some examples that you're going to see on the assignments as well, okay? So guys, let me erase this one so I can do another example, and then we'll move on from here. Now, listen, if you've never done this before, it takes a few examples for you to get used to it, but guys, seriously, it's not that difficult once you get used to it. Just take your time, be careful, double check your answers, and of course you are going to see these on the test, okay? So guys, here comes the second example. F of g, we are still evaluating. Actually, let's do g of f of negative 3. G of f of negative 3, guys. G of f of negative 3, and we are still using these two functions right here. So you guys go ahead and give it a try. Let's see what you come up with. You guys try it out. G of f of negative 3. What's the outcome for g of f of negative 3, guys? Mm-hmm. What'd you guys get? Anybody?
Honestly, I don't even know where to start.
You don't even know where to start. Okay. So let's look. We're going to take the -3, plug it into the f function. Substitute the -3 into the f function for x. The answer you find, you're going to take it and substitute it into the g function. So you're going to go right over here. This is your f function right here, okay? So we're going to find f of -3. So you're going to substitute -3 and for x and work it out. So you get -9 plus 4, which gives you a -5. So when x is -3, f of x would equal to -5. Now, this -5 becomes the inputs or the value of the g function. So now you're going to go into the g function and substitute the -5 in for x and then working it out. So you get -10 minus 1, which gives you a -11. So the bottom line is this: g of f of -3 turns out to be a -11. Now, remember earlier we composed these two functions already to find g of f of x. Remember that? So on this one right here, guys, if I were to go back just a minute to that g of f of x function and double check it against this function, look guys, g of f of x previously was equal to 6x plus 7. So if I'm finding g of f of -3, this would be 6 times -3 plus 7, which gives you -18 plus 7. And -18 plus 7 is -11. See, same thing. All right. Now, like I said, I am going to do some examples with you guys. If you're not comfortable with this, that's okay. I am going to do some additional examples with you.
So,
Go ahead.
so basically it's like you take the answer you would get with the f function and then for the x and plug it into the g function, and then that's the answer for the problem?
Pretty much for the second one, but it's the reverse for the first one.
So if it's f in the front, then it's just the other way around?
Yeah.
Okay.
All right, guys. So let me do a couple more examples. Okay, at least one more. All right. So you guys saw earlier where I wrote down these problems. F of x is square root of x, while g of x is equal to x plus 4. So we're going to do part A, which is f of g of x. This is how you're going to see the problems in the assignment. And then part B, you'll have to do g of f of x. And then of course, part C, they're going to ask you to evaluate, maybe find f of g of 0, something like that, okay? And then part D, they might ask you to find g of f of 1. I'm just making this up as I go along, okay? So guys, look, for part A, they want you to take g and plug it in here for x. That's what they want you to do. So when you plug it in, you're just going to end up with the square root of x plus 4. Because you are only replacing the x, you're replacing this x with x plus 4. That's what you're doing with this one, okay? So that's it for this one. Now, on the other hand, if they want you to figure out g of f of x, you're going to go ahead and take the f of x, go in here, and replace x with it. So if you're going to substitute square root of x into the g function, then you're going to have your substitution of the square root of x, and then plus 4. And that's it. Now, for the evaluation part, part C, they want you to take 0, plug it in for g, the answer you find, plug it in for f. So if you take 0, guys, you plug it into the g function, g of 0 will be 0 plus 4, so that gives you 4. So If this one is 4, you take it, plug it into the f function. So f of 4 will be the square root of 4, which gives you 2. So this one will turn out to be 2. Any questions? Uh-huh. All right, guys, so let's do this last one. We're going to take the 1, plug it into f. The answer we find, we plug it into g. So on this one right here, we're going to do f of 1, which gives you the square root of 1. Square root of 1 is 1. That becomes the g value. So we're going to substitute the 1 in for g. So 1 plus 4 into the g function gives you 5. So there's your outcome. Now, can we double check these? Of course we can. If we take 0, guys, and plug it in here for x, 0 plus 4 is 4. What's the square root of 4? 2. If we take 1, we plug it in here. Square root of 1 is 1. 1 plus 4 is 5. Doesn't that make sense?
I lost you in the middle of C.
Say it again.
I lost you in the middle of letter C. I got to the G is 0 equals 0 plus 4, and I got that 4 makes sense.
Right?
And then after that, I completely lost you.
Okay, so now once you get the 4, you go into the f function and plug it in. Okay, so you do g of 0, which is 0 plus 4, like you said, you got 4. So this 4 becomes the input for the f function. So you go into f and you plug it in for x and work it out to get your 2. Does that make sense?
It makes sense when you say it, but like if I look at it, like I don't even know, like the other girl said, I get very confused as to where to start.
Okay, you always start over here with the number and then work backwards. You see how I'm going backwards? So this number right here goes into the function that's the closest to it. And then once you get that answer, you take that answer, plug it into f. And you do the same thing with letter D. So the 1 goes into f, the answer you get goes into the g.
So C and D, you kind of backwards, but A and B, you go forwards?
No, it's the same thing. See, this one, you're taking all of what g is equal to, plug it into f. All of what f is equal to, plug it into g. It's still the same thing. It's just substitution.
Yeah.
Yeah, it's substitution.
Okay.
Now, again, I'm going to do additional examples with you once I'm done with the recording, but it will become clearer to you. If this is your first time doing it, guys, you have to give it at least 3 examples in order to really get it, okay? So here's a third example. This is going to be our third example, and this is going to help us segue into the next part of this, okay? So this one, we have 2 functions. F of x is equal to 6x minus 3. While g of x is equal to x plus 3 over 6. Now, they want us to find f of g of x, of course, just like with the previous one, that's part A. Now, part B, they want us to find g of x. So guys, let's go ahead and work on this one. So for the first one, I'm going to try and use some different colors here, guys. So bear with me, okay? We're going to take the g function and plug it into the f function. So it's going to be 6 times. Inside the parentheses, here comes the substitution. X plus 3 over 6. I'm substituting in g, okay? So that's the substitution, guys, for f of g of x. You notice how I took the g of x and plug it into f of x for x? So now I am going to simplify this out. So what do I end up with? This cancels out with that, leaving me with x plus 3 minus 3. These 2 cancel out, so I'm left with just x. So that's the first one. Now we're gonna go ahead and do the second one. For the second one, guys, again, let me use a different color so I can convey this, okay? I'm going to substitute f of x into g of x. So here's the substitution of f of x into g of x. So this is what I end up with. Now, I'm going to simplify this. Negative 3 plus 3 cancels out, leaving me with 6x over 6. The 6's cancel out, leaving me with x. So guys, what do you notice just happened? F of g of x is the exact same thing as g of f of x. And there's a reason why it turned out this way, guys. There's a relationship between the f of x and the g of x function, which is what we're going to go into next, which leads us into lesson 1.7. Yeah. All right. Are there any questions for me? Well, you know what? Let me ask you guys this, okay, before I move on. What if I were to ask you to evaluate this function for f of g of 7? What would the answer be? F of g of 7. Come on, guys. What's
So,
the answer?
would we be plugging in 7 into the g function? And
Yes.
then the answer would go into the f function, and then we.
Right?
Okay. Because I
So
when you
that would be 39
then it
plus
gets
3 is 42 divided by 6 is 7.
Yes. Very good. And then what about the second one? What do you think it's going to be?
42 plus, or no, I thought I just said that one.
42 minus,
Won't it be 7?
yes,
It's gonna be
it would
7
be
again.
7.
Because if x is equal to x, it's the same thing.
Yeah, because both f of g of x and g of f of x are x. And so if we're evaluating f of g of x, which is just x, the answer would just be 7. Same thing. If we're evaluating g of f of x, which is just equivalent to x, the answer would just be 7.
Do you mind writing out this example so I can see it visually? Because I don't see how you guys got to 7.
Okay, what we're saying is that we've already composed the two functions.
Well, no, I see that. I see
Okay.
how they equal each other. I understand that part, but I just don't, I don't know. I plugged in 7 for the function of g, and it's 7 plus 3 over 6 equals 10 over 6, but I'm just kind of lost after that. I don't know if I'm doing it wrong, so that's why I wanted you to write it down if you could.
Okay, all right.
What I'm trying to say.
Yeah, I do. All right, so are you okay with the f of g of x, or you want me to do that as well?
Just both, please, if you don't mind.
Okay, all right, so let's look. So f of x is equal to 6x minus 3, while g of x is x plus 3 over 6. Now, I think what we were trying to say to you is this. Because you already have the composite functions, you don't have to do all that work, okay? This turns out to be 10 over 6. Now, if you take that 10 over 6 and plug it into the f function, okay? F of 10 over 6. Notice I didn't reduce it, guys. And
Okay.
it's okay. It's okay. 6 times 10 over 6 minus 3. The 6's cancel out.
Oh,
That
okay.
gives you 10 minus 3. That's 7.
Oh, okay. I see it now. I didn't finish. I'm like, wait, am I supposed to reduce this or not? So, okay. For explaining.
Do you want me to do the other one too, or are you good?
No, I'm good. I get it now. Thank you.
I did
All right.
mine differently, and I don't know if it just, I happened to get the right answer, but I took 6x minus 3 and put the 7 in.
Yeah. So you
And
did.
then, so I got 39.
Right.
And then I took the 39 and put it in the x plus 3, which gives you 42 divided by 6, which is 7.
Okay. Now that's why you have to be careful, because you were doing g of f of x. What I did was f of g of x. Okay. They don't necessarily equal out to each other all the time. Every once in a while, it happens they equal out to each other, but that's not always the case. So what you're talking about is g of f of x. And yes, if you do that, you get 42 minus 3, which is 39. Then you take your 39, you plug it into the g function. So you get 39 plus 3 divided by 6, which gives you 42 over 6. So you get your 7. Yeah. So that's
we can't do it that way?
You can, if they ask you for it, g of f of 7. Remember, we had to do both G of f of 7 and f of g of 7. So be careful.
Wait a minute.
Mhm.
I did the f of g of 7, and then g of f of 7 is that the bottom one?
Yes, that's the bottom one.
Okay.
That's the one that you did. This one right here. That's the one that you did.
Okay, so I guess what I'm not seeing is how I did it and how you did it, where it was 10/6 and all that. Like, I'm not.
Tested positive for the virus. The White House
Okay, because that is two different functions. You have f of g of 7 and g of f of 7. I think you only did the one on the bottom,
again on Saturday.
whereas we also have the one at the top with f of g of 7.
It had
You see what I'm saying?
didn't want to give any.
Okay,
No.
all right. So let me do this for you. So then remember, there's two basic functions, okay, composite functions. We have f of g of x. Remember, I gave you two problems to do. F of g of 7, okay, that's for f of g of x. And then the other one is g of f of x, okay? And I asked you to evaluate g of f of 7. So I gave you two problems.
Attended last week's Rose Garden event.
So this one, you take the 7, plug it into G, find the answer, plug it into F. This one, you take
That one I
7,
got.
plug it into F, find the answer, plug it into G.
Has postponed all floor
So
activity
7.
October 19th after 3.
Yeah, this is the one you did, Jennifer, the second one, where you did 6 times 7 minus 3.
Okay.
Yeah, that's the one you did. It gave you 39.
The f of g of 7 should be 7 plus 3 divided by 6.
Right, 7 plus 3 divided by 6. And then you got to take that and plug it into the other function. 7 plus 3 divided by 6 is going to give you 10/6. Then you have to take that and plug it into the other one. Whoops, that's a 6. And then minus 3. So this cancels out. So you get your 10 minus 3. So that's how you get your 7. All right.
Yeah, but don't erase that yet.
No problem. So guys, yeah, this is gonna help us segue into lesson 1.7, which is on the inverse functions, and the inverse functions are gonna go by very quickly too. Okay. Let me see here. You good, Jennifer?
Let me just take a quick picture and then I'll be good.
Remember, it's a video, Jennifer. You can always go back into it. All right. Now, normally, guys, if we're in the classroom, I give you a nice example on how to use this with real life. You know what? I'm just going to tell you quickly. So let's say you go to Macy's and they have a 30% off sale. But of course, Macy's is known for their Macy's card. If you use it, you get an additional 20% off. So pretty much the first discount is 30%. The second discount is 20%. So the question I always ask the students is, does that mean that you get a combined discount of 50%? No, no, the combined discount will not be 50%, okay? So the first discount, guys, would be represented as 30% off. So the question is, how much are you gonna pay for the item? It's 30% off. You pay 70% for the item. And 70% of the item would be 0.7. That's what percent you're going to pay for the item. For the second discount, it's 20% off. And because it's 20% off, what percent of the original price are you going to get to pay for? You're going to pay 80% of the original price, which would give you 0.8x. So if we were to combine the two discounts together, f of g of x, guys, the combined discount will not be 50%. Rather, it's going to be 0.7 times 0.8 times x, guys. So it's going to turn out to be 56%. Look at that. So the combined discount is actually 44%. It's not 50%. This is a business. They're in the business of making money. So they're not just going to go ahead and give you stuff away like that for free. And if you want to double check this with an example, check it out with an item you purchased for $50, guys. Apply the 30%, apply the 20%, and see what it comes out to. No, they do not combine the discounts together and get 50% off, all right? So I can't elaborate too much on that, but that's how we use this in the real world, guys. So I am going to go into the inverse functions now with, by the way, you're not going to see a problem like that. I just wanted to relay it to real life, okay? We're going to talk about the inverse functions, guys, and the last lesson will be on the circles. The inverse functions, I mentioned them at the beginning of this chapter when we talked about relations and functions, okay? Remember way back when at the beginning of this chapter, we looked at a relation, guys, as a set of points. And then I briefly mentioned the fact that you can find the inverse of a relation, which is denoted by this -1 here, the inverse of a relation. And the S notation is important. And when we're finding the inverse of a relation, guys, all we're doing is swapping X and Y. Now, what does that mean, really, seriously? As in X becomes Y, Y becomes X? Well, let's look. If we were finding the inverse of relation A here, the inverse, if we're going to swap X and Y, would become 2, 3, 1, 0, 2, -1, and then -2, 2. Now, to really understand this, guys, I have to graph this on the XY plane. I'm going to go to the XY plane and graph this so you can see what I'm talking about. Because just telling it to you, explaining it to you is not sufficient. It's better to show it to you, okay? So guys, I am going to use different colors for these points. So the original relation has these points, 3, 2, right here. 0, 1, right here. -1, 2, -1, 2 is located right there. And then 2, -2, 2, -2 is down here. Now, I am going to do the inverse, guys. The inverse of the points, I'm going to graph, I'm using a different color. 2, 3 is right there. Then we've got 1, 0, which is located right here. 2, -1, which is right there. And then finally, -2, 2, -2, 2 is way over here. Now, guys, I'm going to help you out just slightly so you can see what I'm talking about, because sometimes it's difficult to see. I'm going to draw a diagonal line that goes through the origin. Now, tell me what you guys notice about the points in red versus the points in blue. What do you notice about the points in red versus the points in blue? Yeah. Anybody?
It's a reflection.
Yes. Ooh, who said that?
It's like 90 degrees, maybe.
It is a reflection. And they are reflecting across this line right here. This line right here, guys, goes through the origin. The slope is 1. So if a line goes through the origin, 0, 0, and the slope is 1, what's the equation of that line? Well, that line just happens to be y equals to x. So essentially, a relation or a function in its inverse always reflects across the line y equals to x. Always reflects across the line y equals to x. Now, why is that? Because y becomes x and x becomes y. That is why, guys. So next, here's what I'm going to do. Remember, guys, there's a question on the table here. Why did f of g of x and g of f of x turn out to be x when we did those two previous equations? Okay, that's the question on the table, and I'm going to answer that for you, okay? So to find, we're going to learn how to find the inverse. We're going to find the inverse of a function, guys. To find the inverse of a function or an equation, to find the inverse given an equation. Here, let me write it down, given an equation. Here's what we're going to do, guys. Number one, we are going to rewrite the equation or replace f of x with y, okay? We're going to rewrite it as y equals to, or in other words, replace f of x with y. Here, let me write this down. Replace f of x with y. Now, next, number two, we're going to swap, switch, interchange, however you want to say it, guys. Swap, switch, interchange. It really doesn't matter, x and y. That's important. That's critical. Number three, we're going to solve for y. And then the last step is to include the notation. For those of you moving on to the upper level math courses, notation is important, guys, especially in the calculus sequences. You don't put the right notation, they will deduct some points from you, okay? Include the notation, guys. And what's the notation? The inverse of f of x. Here, let me go ahead and highlight this part for you. The inverse of f of x. So guys, I am going to revisit one of the problems we saw earlier, and here it goes. Are you guys done writing this? I'm gonna go ahead and erase it.
No, not yet.
Okay. And guys, pay careful attention. I'm gonna tell you which ones you're going to see on the test, so make sure you pay attention.
I have a quick question.
Yes.
So when you say include the notation, so you're saying we're replacing f of x with y,
Yes.
and when we include the notation, it's
You're going to replace y with the inverse of f of x.
yeah. So it'd be f.
The
To the
inverse
power of
of f of x equals to whatever.
So in the beginning of the equation, would you be writing what you have circled down there?
At the end of the problem.
Yeah.
Yeah.
Okay. Thank you.
All right, guys, so here we go. Some of you may remember this problem. F of x equals to 6x minus 3. We're going to find its inverse. And so on this one right here, to find the inverse, guys, we are going to rewrite this as y equals to 6x minus 3. Okay? Now we're going to swap x and y. And then we're going to solve for y. So let's solve for y. We start by adding 3 to both sides. This is an addition symbol here, okay? My pen is not writing. X plus 3 equals to 6y. And then, guys, we're going to divide both sides by 6. So the 6's cancel out over here, leaving you with y is equal to x plus 3 over 6. Ooh, some of you should be noticing something. So now I'm going to include the notation. So rather than having y over here, Maddie, I am going to rewrite it as the inverse of f of x equals to x plus 3 over 6. So that's the inverse.
Really, and that's all you do? You wouldn't go, well, obviously you really can't go further, but
No.
that would be the answer.
Yeah, the inverse of f of x.
Oh, you would think it'd be more complicated, but it actually seems
No. Okay, so does this problem look familiar, guys? As in g of x equals to x plus 3 over 6?
Mm-hmm.
So essentially, we found the inverse of the f of x function. It's actually the g of x function. In other words, the inverse of f of x is g of x. Or vice versa, the inverse of g of x is f of x. So if we were to take g of x and find its inverse, it would lead us to f of x. This is why when we found f of g of x, guys, we got x, and we found g of f of x, we got x. It's because f of x and g of x are inverses. So you can show whether or not two functions are inverses by finding their composites. If both composites turn out to be x, yes, they are inverses of each other. Any questions, guys?
In about 2 hours, I'll be completely confused, but right now I'm good.
Okay, so then let me break it down for you in terms of what you really need to remember, okay? Here's what you need to be able to do, because it's all about being able to apply the information to various problems, especially during the test. So if I give you a problem like that, like this one right here, and I ask you to find the inverse, find the inverse. The question you have to ask yourself now, Jennifer, is, will I be able to figure out the inverse of this, okay? If you can do that, then yes, you're getting it, okay? So we just go through the step-by-step sequence I gave you earlier to find the inverse. So we replace f of x with y.
Y equals s plus 2 over 3.
Right? And then we
Up to the
swap
third.
x and y.
X equals y plus 2 to the third.
And next, we're going to solve for y. Now, there's a power here. The y is inside the parentheses, and it's being raised to the third. This is all about inverses. What's the inverse of the third power? The cube root. Guys, remember, it's about inverses. So cube root of x is equal to y plus 2. Remember, we're solving for y, so subtract the 2 from both sides. This is all about inverses, guys. So cube root of x will equal out, minus 2 will equal out to y. Essentially, we're done, but we got to include the notation. The inverse of f of x will equal to the cube root of x minus 2. And that's it. There will be one like this on the test.
Show us how simple it is and then throw cube roots in. I see how you are.
What? What? That wasn't that bad. Come on now, Jennifer. Now see, okay, now you're making me feel a certain kind of way because I was thinking about throwing a fraction in there. Oh my gosh. Anyways, guys, yeah, but you have to keep adding to this material. By the way, guys, this is stuff that you learned back in grade school. We just keep adding to it. That's all it is. Math is a building block. It's like one of those Legos. Lego forms that kids play around with. They create all these castles. They never end. They keep going and going. They keep adding pieces to it. That's all it is. All right, so let me do the one with the little fraction, guys.
Yeah, but how do you take a fraction of a castle?
Okay, Jennifer, don't get me started.
I try to take your real stuff and put it in, but my bank doesn't allow imaginary numbers.
Oh, did you say a bank?
I try to go to the bank and tell them I have some imaginary zeros in my account, but they don't listen.
Okay, Jennifer, listen. Compound interest is coming up. I hope you're ready when compound interest comes
Oh,
around.
geez, Louise.
Jeez Louise, that's probably one of the greatest formulas in mathematics, compound interest. It is the greatest formula. Okay, that's what allows your coins to multiply, your money to multiply and grow exponentially, okay? That's coming up in chapter 4 with exponential functions, okay? Be ready for that, Jennifer.
Still on chapter 1.
Your coins are positive and not imaginary. Oh Lord, okay. I love it, Jennifer, but I'm with you. Make the math relate to money, and if it's relatable with money, people will get it. People will want to do it. All right, guys, so let's quickly do this one right here. But all I can tell you about this one is that I like to think of this in terms of owing money. When you owe money, there's no way you can make your money grow if you're owing money to people. It's when you don't owe people money, your money can grow. So stay out of debt. Does that make sense? Sort of. Okay, fine. I'm stretching it, aren't I? Okay, guys, let's go ahead and move on. Let's solve this one. We're going to swap x and y. And so on this one right here, I'm going to subtract 9 from both sides. So I get x minus 9 is equal to 4 over y. I know, the y is in the denominator. We're trying to solve for y, guys. It's a fraction. How do you get rid of a fraction?
It's easy.
Yes, it is. How do you do it, Jennifer?
You multiply.
I don't know. You multiply.
Multiply by what?
1/4.
Oh, you were almost there, Jennifer. Remember, we're trying to get rid of the fraction. When we're getting rid of a fraction, what do we multiply by?
Oh, that's right.
Reciprocal, right?
The
The reciprocal.
denominator.
The denominator.
The denominator.
Yeah. Okay, so now we get rid of the y. I'm running out of room here, guys. Okay, my
started
little
doing that.
tablet screen is limited, okay? So I am going to erase this portion right here so you can see what we have left over.
Okay, so I did start doing that, but then I thought I was wrong because we were trying to isolate the y, and now we're putting the y on the same side as the x, so we're defeating
Yes.
the purpose.
We're getting there. We're getting there. We're getting there, Jennifer. We're almost there, actually. And so x minus, is it 4 or 9, Shazam? I just blanked out. Ooh.
Oh, well, y
Okay.
x minus 9 parentheses equals 4.
Okay. So now, Jennifer, here it is right here. Look, y is multiplying the parentheses. So we want to get the y by itself. What should we do to isolate the y?
Divide by x minus 9.
Yes, Jennifer, you got it, girl. You got it. Okay. That's it.
Wow.
I'm telling you, you got this. And you're done just like that. I mean, of course.
Just like that.
Yes,
It was
just
that
like
easy.
Yes, it is, lady. Yes, it is. Okay. Guys, I don't know if you can tell, but I love math and I love having. Okay, I'm sorry. I know I'm the math teacher. I'm the math instructor. Of course, I'm going to love it. All right. So, guys, that's it for this one. Seriously,
She's
it's
high
not
on
that
math.
bad. You know, there's a couple of things I should mention to you very briefly, but I don't want you to get stuck to these things because, guys, listen carefully. This is not what the entire section is about. This is more about being able to find the inverse of a function. Given a function, you have to be able to find its inverse. Okay. Now, when we talk about a function and its inverse, guys, be careful. Remember earlier we were talking about the radical? The square root of x, guys? The domain of the square root of x is from, well, you know what? Let me make it a little bit more precise. Let's make it more precise because I need to make a point, okay? F of x equals to the square root of x minus 3. The domain of this one would be all x is greater or equal to 3. Or if we write this in a different notation, from 3 up to positive infinity. Now, the range, I know we haven't talked about range, guys. Domain is x, range is y. The range is the output, the outcome, okay? The outcome for this problem can be any value, guys, from 0 up to positive infinity. Now, when we talk about finding the inverse, remember we're swapping x and y. So if I were to ask you this question, what is the domain and the range of the inverse of this function? Remember, guys, we're swapping x and y. So if we were looking at the inverse of this function and we were finding its domain and range, the domain and range of the inverse of this function, then the range would become the domain from 0 to positive infinity. And the range, guys, would be the domain from the original problem. In other words, what are we doing? We are swapping x and y. So the domain becomes the range becomes the domain. Vice versa, guys. Yeah. So basically, you're swapping everything. You're swapping domain and range. You're swapping x and y. That's what this is about. By the way, would you guys be able to find the inverse of this little function right here? Shane, you have a question? No? All right. If you have a question, guys, just turn on the mic and have a conversation with me, okay? Now, guys, I know some of you, go ahead.
Y equals the square root of x minus 3. X equals the square root of y minus 3. We're going to square both sides.
Right.
X squared equals y minus 3.
Right.
Add 3 to both sides. So x squared plus 3 equals y.
Right. See, Jennifer, I told you got this. You got this, girl.
And then f
the only thing, hold on, Jennifer.
1.
The only thing is, Jennifer, this is where the domain, remember I told you the domain becomes a range, the range becomes a domain. You have to put the restriction on the domain of this one. The domain of this one is going to be all x's greater than or equal to 0. Because you don't want to plug in the negatives. The negatives won't work out for this problem. Yeah. So be careful with that one. Go ahead.
And then you put the f to the negative 1 power of x equals x squared plus 3. And then do you write the restriction too?
No, the restriction is this one right here, so you're good. Yeah, just the positive side.
I built a castle.
Yes, you did. Okay. See, I told you you're capable of doing this. All right. Most people are way more capable than they think they are, guys. Seriously. So now one last thing I want to say, guys. I'm going to try and cut it really quick because I cannot leave you guys without saying this. The only functions that have an inverse, guys, are one-to-one functions. Now, the quickest thing I can tell you about a one-to-one function is this, guys. Remember when we did the vertical line test? And the vertical line test basically said, if you draw a vertical line anywhere through a function, through the graph of a function, guys, if it intersects the function once and only once, it's a function. Well, along with a vertical line test to determine if it is a function, there's also a horizontal line test. And the horizontal line test basically is the same thing as a vertical line test, but this time it's a horizontal line. This helps us to determine if we have a one-to-one function, okay? So as in, for every x, there's exactly one and only one y value. So how do we do the horizontal line test? You draw a horizontal line anywhere through the function. Ooh, let me use a different color. If it intersects the graph once and only once, it's a one-to-one function. But guys, notice everywhere we draw this horizontal line, it's intersecting the graph more than once. So that means that it's not a one-to-one function. And since it's not a one-to-one function, it does not have an inverse. Only, let me write this one down. This is why I'm telling you this. Only one-to-one functions have an inverse, guys. Only one-to-one functions have an inverse. If it's not a one-to-one function, it doesn't have an inverse. All right? As in, it's going to fail the horizontal line test. All right. Don't worry too much about that. I'm not going to linger on it. I just needed to mention that to you guys. Normally, if I had more time, I would go in through some examples and show you guys what I'm talking about. But I don't have that much time because I want to go ahead and get to the last lesson. And the last lesson has a bit of graphing in it too, guys. But it's easy. This is material that you're comfortable with, okay? Lesson 2.7, this is the last one, is on the circles. Yeah. The circles represent all points equidistant.
Is this 2.7 or 2.8?
Say it again.
Is this 2.7 or 2.8?
2.8, thank you. Okay, all points equidistant from a given point, guys, called the center. And the center coordinate, we refer to it as h, comma, k. All right? Now, the distance from that given point to the center is called the radius. The distance from that given point, the center to any point on the circle, guys, is called the radius. All right, that's the segment from the center to any point on the circle. Now, I'm getting ready to erase this. That's why I'm lingering here, okay? So guys, here's the equation we use, the standard form. The standard form of a circle. The equation of a circle to pick up all the points on the circle. It is, guys, x minus, that's an x, okay, minus h squared plus y minus k squared is equal to r squared. Now, guys, remember the center is h comma k, while the radius is represented as r. So what in the world are we going to do with these? So here's a couple of things we're going to do, guys. Number one, you will be given a center, such as 2 comma negative 4, and the length of a radius. The radius is 4 units. And the question will come up, write the equation of the circle. Write the equation of the circle. So guys, for this one, all you do is go into your formula and substitute these values in. We're going to substitute the values in. So the center is h comma k. This is your h value. Let me use a different color. That's h, that's k. And your radius is 4 units. So we're going to come in here, plug in 2 for h, negative 4 for the k, positive 4 for r, and then work it out. So we get x minus 2 squared plus, be careful with this part, y minus a negative 4, guys. And because we're minusing a negative, that is going to turn out to be what? A positive. Oops, whoops, I'm putting a 2 here. That's supposed to be a 2. There we go. And y minus negative 4 is going to be positive 4. And then 4 squared is 16. So guys, there's your equation. Now, I know what some of you are thinking. Do we have to graph these? Do we have to find the domain and the range? Yes, we do. But hang on, guys, not yet. Let me do one more like this. Okay, here's another one. The point, which represents the center, is negative 3 comma negative 1. The radius this time is 3 radical 2. So now we're going to go ahead and go into the formula once again, and we are going to substitute everything in. And so guys, let's look. On this one right here, we get x plus, are you guys okay with the plus? I'm putting a plus 3. Do you guys see where the plus is coming from? Yes, no? No?
Yes.
Okay. Now, I'm pausing here, guys, because we're going to have to take the 3 radical 2 and square it. If we square 3 radical 2, this is the same thing as saying you have 3 radical 2 times 3 radical 2. This is one way of doing it. 3 times 3 gives you 9. Square root of 2 times square root of 2 is square root of 4. Square root of 4 is 2, so 9 times 2 gives you 18. Or, how about this? 3 squared is 9, square root of 2 squared is 2, and 9 times 2 is 18. So guys, when you take that 3 radical 2 and you square it, you're going to get 18 from that. All right, so now, guys, here's the big ones. Here's the big ones. You will be given an equation, the equation of a circle in the general form, and then you have to transform it to standard form. Okay, it's almost 8 o'clock already. Shazam. All right, guys. 8 o'clock, I'm going to be done. I'm not going to keep you guys past that. Okay, given the equation, I'm just going to do 2 more examples and I'll be done. The equation of a circle in the general form, given the general form of a circle, guys, you have to convert it to standard form. Now, just to expedite this, guys, I'm just going to write out the problem. Instead of giving you the actual form, I'm just going to write out the problem. X squared plus y squared minus 10x minus 6y minus 30 equals to 0. This represents the general form of a circle. Obviously, it doesn't look like the previous examples we did. So you have to take this and rewrite it in standard form, so it looks like the previous examples we did, okay? So guys, on this one right here, here's how we're going to do it. We're going to go ahead and pay attention, guys, okay? Because I'm going to do 2 examples like this, and yes, this is on the test. We're going to take, here, let me use a different color. We're going to take the negative 30, move it over. And I am also going to rewrite the problem so that I can group the x terms next to each other. I'm grouping the x terms next to each other. And guys, when I say grouping them, I'm just meaning to write them next to each other. That's it, okay? So I'm writing the x terms now. You will notice there's a blank here. This blank is there for when we do go in to complete the square, so we can write this in standard form. Now guys, here comes the y terms, y squared minus 6y, and then plus another blank, because we're gonna have to complete the square on the y term, and then move the 30 over. I'm pausing. So guys, what did I do? I moved the 30 over. I am writing the x terms next to each other, the y terms next to each other, AKA I am grouping x, I'm grouping y, and I'm getting ready to complete the square on the x term as well as the y term. I am going to complete the square twice so I can rewrite this in standard form. All right, guys, so here comes the process. I'm gonna do this slowly so you can get it. So to complete the square, guys, I'm gonna do half of the negative 10, half of the b term. So that's gonna give me negative 5. Then I'm gonna square the negative 5, so that's gonna give me 25. This is where the 25 goes. And I'm gonna add it to both sides, guys. I'm adding the 25 to both sides. I'm pausing, just in case you have a question. Like I said, I'm gonna do 2 examples and then I will let you guys go, unless of course you wanna stay for questions. Okay, so let's do it on the y term. For the y term, guys, I'm gonna do half of negative 6. You don't even need to worry about the negative because eventually the negative cancels out. Take the negative 3, square it, you get positive 9. We're gonna add the 9 to both sides. Add the 9 to both sides. Any questions? Okay. I feel like some of you are already getting lost and you don't even know where to start asking questions. Okay. I'm just gonna keep writing until I'm done. All right, guys.
Adding arbitrary numbers.
Arbitrary numbers? No, they're not arbitrary. We're just completing the square on the x terms and the y terms. We learned completing the square back in chapter 1 when it came to solving quadratics. These are all quadratics. Completing the square is another way, another method to solve quadratics. All right, guys. So this is a perfect square trinomial. It is factorable. This is also a perfect square trinomial. It's factorable. Now, everybody can add all 3 of these numbers together. So I'm just going to go ahead and add them together. So this is going to give me 64 right here. Okay. So now let's factor, guys. We want to find 2 numbers that multiply to give us 25. When we add them, we get negative 10. That'll be x minus 5, x minus 5.
Minus 5.
Which we can rewrite as x minus 5 squared. You see that? Yes? No? Ooh, okay, let's do it again. This time, we're gonna go over here. What 2 numbers multiply to give us 9 and add to give us a negative 6?
Y minus 3.
Uh-huh.
Minus 3.
Right? So we can rewrite this as
Minus
x
3 squared.
And so guys, this is our equation in standard form.
Do we have to make the 64 8 squared?
No, you just leave it like that. But wait, we're not done. There's more. The center coordinate, guys. We need the center. The center is the opposite of what's inside the parentheses. So the opposite of -5 will be 5. The opposite of the -3 will be 3. That's the center of the circle. And then they will ask for the length of the radius. The radius is the square root of 64. That would be 8. Now, normally I would do the range and the domain with you guys and graph it, but these numbers are too large. So I'm gonna do that last problem, and hopefully this last problem right
Can
here.
I ask one question?
Yes, absolutely, man.
Is that how did you get rid of the y? Is that second part supposed to be y
Oh
minus?
man, that is supposed to be a Y. Good catch. That is supposed to be
Okay,
a
that's
Y.
where I was
There you go.
confused.
Yes, you're absolutely right.
Okay, thank you.
No, thank you for catching that, Shazam. All right, guys. I'm gonna do one more like this, and then remind me to graph a circle so you guys can see how to graph it and also how to find, you know what? Let's just do it right now. Let's just do it right now. Let's say the center is at 2, 1, guys. The radius is 3 units. And I'm using an easier one because those numbers were too large. Okay, guys, I'm going to sketch the graph of the circle. The center is at 2, 1. All right, so guys, here it is. I'm going to use a different color. The center, 2, 1. There's your center. Now, the radius is 3 units, guys. That means the distance from the center to any point on the circle is 3 units. So I'm going to count 3 units to the right. 1, 2, 3. Plot a point. And I'm going to count 3 units to the left along the horizontal. 1, 2, 3. Plot a point. Then from the center, I'm going to count up 3 units. 1, 2, 3. Plot a point. And from the center, I'm going to go down 3 units. That's 1, 2, 3. Plot another point. And so, guys, all 4 of these points are along the circle. So this is what my circle would look like. Now, additionally, they could ask you to find the domain and the range. Remember, the domain represents your x's. The range represents your y's. So for the domain of this one, guys, that's along the horizontal part. What is the lowest x on the graph? Well, you are over here at x equals to 2, and you traveled 3 units to the left, so this is going to take you to -1. Now, here's another way for you to get that -1. Since the radius is 2 units, I'm going to subtract 3 from 2. That gives you -3. What about the upper limit of the domain? We're going to add 3 to the 2. That's going to give us 5. In other words, if we're sitting at 2, we travel 3 units to the right, that's going to take us to 5. So guys, that's the domain. Now the range, we're going to do the same thing. For the range, we're going to go ahead and figure out the lowest point along the vertical side of the graph up to the largest possible point on the graph. Okay, on the vertical part of the graph. So guys, if we're standing at +1, we travel 3 units down. That's going to take us down to -2. Another way to figure this out, subtract 3 from 1. That gives you -2. Add 3, and that will give you the upper limit, which is 4. And guys, that's your domain and range. Now, believe it or not, guys, it's exactly 8 p.m. And I said I wasn't going to keep you past 8 p.m. So what I'm going to do is stop the recording, and then we can do an additional example if you want another example, okay? So I'm going to stop the recording right now.